What are the ideal amperage and voltage settings for different welding techniques? Imagine you're working on a project that needs a strong, clean weld. Getting the right electrical settings is key to making that happen. Today, we'll look at how to choose the best amperage and voltage for different welding methods. Knowing these numbers helps you avoid weak spots, excess spatter, or burnt-through welds. Let's start with metal inert gas welding, often called MIG welding. In MIG welding, the amperage is mainly controlled by how fast you feed the wire. Faster wire feed means more amps and more heat. Voltage controls the arc length and the shape of the weld bead. For example, if you're using a wire that's 0.23 inches thick, you might set the amperage between 30 and 130 amps. For a 0.30-inch wire, the range is roughly 40 to 145 amps. Thicker wires like 0.45 inches can need up to 150 amps. A good rule is to use about 1 amp for every thousandth of an inch of steel thickness. So, welding a piece of 0.1 to 5-inch thick steel would need around 1 to 5 amps. Voltage usually ranges from 18 to 30 volts. Higher voltage makes a flatter, wider bead, while lower voltage gives a narrower, taller bead. Adjust the voltage so the arc stays steady. If the arc stubs or burns into the work, lower the voltage. If it jumps around or burns the wire tip, increase it. Using charts that match wire size and metal thickness helps find a good starting point, then you can fine-tune from there. Moving on to stick welding, also called shielded metal arc welding. Here, the amperage depends on the electrode size and type. For a 1/16-inch electrode, start around 30 to 60 amps. For a 332-inch electrode, 60 to 130 amps works well. Larger electrodes like 1/8-inch need roughly 90 to 160 amps. Even bigger electrodes, like 530 to inch, can requiring 130 to 230 amps. The goal is to melt the electrode properly and get good penetration without too much spatter or burn-through. Usually, welders follow the manufacturer's recommendations and then adjust based on how the weld looks. If the bead is smooth and penetrates well, you're good. If it's too shallow or spattery, tweak the amperage accordingly. Next is gas tungsten arc welding, or TIG welding. Since TIG uses a non-consumable tungsten electrode, amperage controls the heat and how deep the weld penetrates. For thin metal like 1/16-inch, 20 to 60 amps is enough. For medium thickness, around 80 to 150 amps works. For thicker sections over 1 inch, you might need 150 to 300 amps. Voltage in TIG welding is set by the power supply and relates to the arc length. It's less often changed manually. Proper amperage is vital for a clean, high-quality weld, especially on delicate or precise jobs. Flux cord arc welding, or FCAW, is similar to MIG but often uses different wire types. The amperage is controlled by wire feed speed, just like MIG. Voltage depends on the wire and material thickness. Because flux cord wires deposit more material, they usually need higher amperage settings. For example, a common flux cord wire might need 80 to 200 amps depending on the thickness of the metal. Remember, amperage measures how much current flows and controls how hot the weld gets. Voltage measures the electrical potential difference and affects the arc length and bead shape. Wire feed speed in MIG and flux cord welding directly influences amperage. The thicker the material, the higher the amperage needed. A simple rule is 1 amp per thousandth of an inch of steel. Getting these settings right is essential for strong, clean welds in mechanical engineering projects. Using charts, manufacturer recommendations, and adjusting based on how the weld looks will help you find the best setup. Proper electrical settings lead to better weld quality, fewer defects, and more efficient work. Understanding how amperage and voltage work together makes welding easier and more predictable, no matter which technique you choose.